Colin. Right, so what are we going to talk about? So I want this to be a sort of a discussion, and the second part of the meeting is a discussion. So a little bit about how maintenance fits in with asset management, because I don't think necessarily we all see maintenance the same way. And I should add before I start probably that these are my views and not necessarily those of Network Rail. So what is the goal for a maintenance team? What are we trying to do as a maintenance team? A little bit about reliability-centred maintenance, which we have managed to apply successfully within the railway industry, but is a very, I think, a very good approach for changing the way you look at maintenance and the way it's organised. We'll look at what the benefits of a proactive approach are, and we'll look at some case studies of where a proactive approach has delivered rewards. Yeah, I want to say a little bit about rewarding the wrong behaviours, because I think that as an industry we sometimes enjoy firefighting too much, and we reward people for doing it rather than getting on and quietly doing the job. And then really I want to open it, say, you know, under the question is, if proactive maintenance is so good, why aren't we doing more of it? What are the challenges? What do we need to do? What do we need to change? So this is the this is taken from the Institute of Asset Management's book, The Anatomy of Asset Management, and it shows the various components of an asset management plan. And it's important that it defines asset management as the coordinated activity of an organisation to realise value from assets. And I think that actually describes the railway perfectly well, whether you're a train operator with trains, whether you're an infrastructure owner looking after the track. And obviously the bit I'm going to be focusing on is the life cycle part of it today. So maintenance is very clearly mentioned and discussed in a lot of detail in the IAM's document, and indeed others, the American equivalent and that sort of thing. And as you can see on the block on the left, sorry, on the right, it tells you what sits within life cycle delivery. And number 15 is in there, is maintenance delivery. But it also, important things like configuration management, creating the right assets in the first place, having the technical standards back what you want to do. And it takes you right through the life to disposal. Yeah. And if you're interested in reading more, I can thoroughly recommend the Anatomy of Asset Management by the IAM. But what does it say about maintenance? So operations and maintenance decision making. So the IAM states that the goal for maintenance is to prevent or mitigate the deterioration of performance of assets in service and manage the risk of failures. It is good asset management practice to have a maintenance strategy to ensure a predictable and acceptable level of performance through the useful life of the asset. This includes inspections, testing and monitoring, and preventive maintenance regimes. So whether they're time-based, condition-based or whatever. A lot of our maintenance is condition-based, and we have tasks for that. You note that it does not major on incident management or disaster recovery, which are things which have become very popular in the railway industry. And they become a big focus for maintenance in the railway industry and indeed in other industries as well. So maintenance, in my opinion, should be largely invisible to the users of the system and work steadily and reliably in the background, eliminating the nasty surprises. So I'm sure a lot of you have actually been involved with reliability sentence maintenance, so we'll just quickly refresh this for those of you who haven't or haven't done it for a long time. So for every, and particularly railway assets, heavy engineering assets, if you plot the function of an asset, so that's what you want it to do, yeah, against time across the bottom, there will be, we can apply RCM if there's a point which there is an observable functional failure. Yeah, and we can define the point at which the function has failed. So in a railway context, if we look at an example on the next one, this is a track geometry one. So if the case is that the function we want is the ability of the track to support and guide trains, and against time. So you could say, well, point P can be an alert action limit geometry fault. So there's no mandated actions. You're now aware it's there, and you've got loads of time to plan to fix it before it becomes anything bigger. Yeah. If you didn't do anything, and that's what the PF cares about, the next thing you come to, you start getting intervention limits or possibly rough ride reports. So you've now got a short time scale to actually do some intervention. And if you don't intervene there, you will end up with an immediate action limit fault or possibly a derailment. Okay. So same thing for rail defects. Again, we get detectable visual, ultrasonic or eddy current rail defects. Yeah, we can start the process off long before we get down into the part of the world where we have to have mandated action timescales. So I think there's a bit of a tendency these days that we spend a lot of time operating in this area down here. This area down here. So we tend to be driven by the mandated actions, the minimum action codes in the standard. So there's a big focus on compliance rather than good asset management. And the problem with that is you're never restoring things back to where they are. You're constantly operating in that loop, and you're operating very close to the point of failure. So what are the benefits of operating up at point P? Well, we're a long way from failure for a start. So you can actually plan the work much better. You can have a balanced workload because you can actually work out what you're going to be doing. We're not reacting all the time. We can plan better to use the access we have available. That's an increasing challenge, and constantly asking for short notice access isn't really very tenable. It's much less flexible. Whereas if you're operating well out and as soon as the defects appear and plan them straight away, you can actually plan much better into the access that you do have, albeit limited in some places. But there's bigger things than that as well. If you're operating up again at the around point P, you can actually properly size the capability of the team because you're of control of the workload, the skills needed, and the planning. So we can eliminate things like unplanned overtime. Yeah. And we can get big savings out of managing defects when they're still small, not urgent, and have a minimal performance impact. So I think it's a sustainable business model as well. The challenge, of course, always is we are down here, normally, most places. Yeah, this is where we want to be. And the start of the challenge is how do you get from where we are now to where we want to be? And I think as engineers, we all need to spend time, whether you are a track maintenance engineer in a depot or indeed a section manager, thinking about what do we need to do to actually get from one place to the other. And there's various things we can do. Sometimes we can target CapEx works. So for instance, successful re-railing and things like that. Sometimes it might need just applying different standards to make sure that we do act earlier. It doesn't necessarily need to mean a lot more resources. That really is driven very much by how quickly you want to get from A to B. And we'll look at the example of rail management in Wales in a little while to show where we got in 10 years of applying our own standards. Okay. So I think the really important thing to remember is don't. So our track standards represent the minimum standard. They're there because if you go beyond them, you're into unknown territory, if you like. And by maintaining at that level, i.e. you deliver the min-maxes when you have to, won't deliver a reliable railway or a comfortable permanent way. It can still be safe, but it will deteriorate in its operational performance. But if you take a focus of have your maintenance driven by reliability and good ride quality, we will certainly deliver a safe railway at the same time. So that's perhaps the shift that I'm thinking about. Another big challenge we have, I think, as an industry, and again in other places, is where the new work found matches and balances with the work completed in the job bank, then the job bank will enable you to predict quite accurately the cost of delivery, because you know what staff you've got, you know what hours of work you've got, you know what vehicles we need to support it and things like that. So if you can manage the changes by reprioritising based on re-inspection to actually manage the workflow. And again, this gives us a sustainable situation. But unfortunately, we're not always like that. So if you're faced with an expanding work bank, i.e. we're finding more work than the work that's completed, the job bank will steadily get bigger. So reprioritisation based on re-inspection becomes increasingly difficult and potentially impossible to manage. And I can remember a few years ago, our off-track colleagues were doing block reprioritisation of work because they just couldn't manage the job bank anymore, which really means you doesn't tell you anything anymore if you keep reprioritising everything. The tendency is also we actually do the work when it becomes a compliance issue, or we don't do it at all because we never put it into the job bank. So the sustainable funding is no longer sufficient to deliver the sustainable volume. So let's go on to look at a couple of case studies from my experience. So the first one's looking at management of rail defects in Wales Route, and some of you will know that I was the RAM track for Wales when it was first formed, and this is something that I worked on with my team down there and the wider maintenance team about getting this done. This was very much driven by our rail management engineers. So what did we do? So the first thing was thinking about what happens to defects. Well, if you don't do anything with a rail defect when you first see it, yeah, over 80% of them, particularly things like squats and things like that, will eventually grow to an actionable size, and you're forced to take them out, possibly with a speed restriction in place at the time. So what we decided was particularly we would focus on visible rail defects, and everybody is encouraged to report visible rail defects. Put them into the RDMS system, get them verified and into the work bank. So we stopped using the 3 engineers 3M retest to engineers timescale, and we gave every defect a minimum action code. So a lot of the 3Ms became 6 months or a year defects, but they all went into the job bank to be done. So that presented some challenges at first, because you imagine there's lots of conflicting priorities at the beginning. We're still dealing with quite a lot of urgent defects and things like that. But what we look at now is what happened over the 10-year period. And these are some information taken from the Rail Defect Management Plan of Wales. And I think the important thing to note is we didn't have any additional resources. So we didn't have any more welders. We didn't have any more supporting staff. It was all done by just changing the attitude and the approach to how we manage defects. So what's happened? Well, defect numbers have increased. So this is because we've got increasingly old rails. Over the years, we've seen this runs from 1999 up to 2021. So we've got better inspection methods. We can find things now that we couldn't find before. But I'm sure those of you who were around a few years ago will remember when we suddenly managed to ultrasonically detect longitudinal verticals, and we found the bloody things everywhere. So we actively look for and encourage reporting of visual rail defects by all track inspection staff. Yeah. We use RDMS for all our rail defects, so we've got a picture, global picture of what's going on. And it's also important to put them in as individuals as well, because we find that if you put defects in as clusters with one defect number, you don't have a true picture of where you're going with it. So early intervention and better planning means that the trend is now leveling off. Yeah. And it can be seen from the bottom chart. The numbers of defects in the track have remained broadly stable from 2019 onwards, which is where we want them to be. So we've got a balanced job bank, in other words. And this indicates that we're likely to have the correct capability to manage rail defects. Through working with the current access constraints is proving a challenge. So obviously, when we did abandon all the red zone working, that has presented a challenge, and particularly things like good work scoping, and that was one of the casualties which we're fighting to stick with. So our compliance have also got better. So over the years, you can see we've slowly dropped down, and the numbers of overdue defects are very, very small now. And we've also brought down the number of TVs we needed for defects as well. Yeah. And it's worth noting that in Wales, we didn't use the TRK 1101 management of rail defect removal timescales. We manage all defects through the TV process. Okay, so over the longer term, we've seen some benefits. This, for me, though, is probably the chart which is most interesting. So down here, this is the rows, this is the years. Yeah, this is the number of days you action your defect. Yeah, so from 2 days up here up to 1,000, that's 3 years, isn't it? Yeah. So and across the bottom, these are just the headings. So what you can see is we've gone from the early years where we had the bulk of the defects were relatively short timescales, and we had few long-term timescales, to the situation we're in now, where there's few short-term defects. You will inevitably get a few short-term defects because it's a crack in, encountering a wobbly wheel on a train or whatever. But as you can see, the defect numbers have shifted towards much longer timescales, and there's significant numbers in 2 and 3 year timescales. And we have eliminated over time all the 3M defects. So, and these are some more key trends. One of the other big benefits for us is that we've had less train delay due to broken rails and serious rail defects. We've had a lot less clamping of defects, which is good because clamping is always a disruptive process, isn't it? We've got less 48 out of 7 day defects. As you can see, that's tailed right away. Yeah. And we've got better at planning into the available access. Broken rails is also quite interesting for Wales. This is 1999 to 2009. And 16 of our broken rails in that time were directly attributable to defective freight train wheels. So despite all our good asset management, the freight operators don't always help. We've also changed the method of removal, and we've moved away generally from re-railing, which is the blue one at the top, and much more towards arc weld repairs and railhead repairs. So the HRW, the railhead repairs. That's been stuck for a little while, but we're getting going that way now. And also by tackling small, we found we've moved a significant number of defects by just grinding them out. Because if they're just a surface defect, they are very quick and easy to remove, or shallow. So it means, again, we can get more done in short access opportunities. So in conclusion of that bit of it, so the proactive approach to rail defect management in Wales is yielding benefits, and the defects are well managed. The numbers of broken rails and serious rail defects with their attendant train performance consequences have fallen, and remediation is now focused on quicker, less costly and less intrusive interventions. So, for example, by doing a lot of weld repairing, that we do little rail changing for defects now, unless you get a big cluster where it's more cost effective. And it can be demonstrated that numbers of rail defects in Wales route and the resources needed to manage them are quite clear. And one of the DUs has got a self-imposed target to get their defects down to a rolling 250 rail defects in track. Which I think is a really good place to be. So the second one to really look at, again, proactive, is when we relaunched 053 some years ago, we had a lot of concerns. So we issued it again, reissued it. So to improve the guidance on when a switch was suitable for repair, because it was quite obvious after Princes Street Gardens and some of the other derailments that people were continuing to try and repair things, and really there was nothing left to repair, and we were very, very close to the safety limits. And again, to encourage a more proactive approach to switch management. We had a lot of feedback from stakeholders that this would create an unmanageable workload, and an increase of TVs to manage this. But the following charts were taken from the PIR, which we did a year after implementation. This is just a couple of charts for that. Yeah. So we dropped the defect count by about 1,000. And a lot of this was to do with proactive grinding. And as you can see on the diagram there, dealing with lipping and dealing with that reduced the amount of switchblade damage we're getting. Yeah. And we've increased the amount of lipping, grinding and that sort of thing. And again, it's reduced the amount of rail that we've had to change, switches we've changed. The concern about TNCs turned out to be unfounded. So after a year, it was all virtually the same, a slight reduction, but basically the same as it was before. And the band to facing moves was, I think, probably the biggest success. So we reduced the block to facing moves by about 100 or about 30% in the course of a year. So that's a huge win for train operations. Okay. So the conclusions to that. So the shifting to a more proactive management of switches over only 1 year resulted in reduction in the number of defects, reduction in numbers of block to facing moves events, and no increase in the number of TVs. Yeah. And we've only had one facing switch derailment since then, which was the one at Sunnyside in Scotland, which was it was a hazard 2 failure, but it was due to a failure to apply the standards correctly on site rather than any failing in the standard. So what's going on at the moment? We're working very much on 1054. It's come out now. This is the cast crossing inspection. And again, we've reissued it. So we've tightened up the inspection standards. And various other things in it, because the recent experience has indicated that cast crossings on our main lines are not lasting as long as would be indicated by their design lives. So we've got crossings on the East Coast main line which last 2 to 3 years, rather than the 18 to 20 years they should. So obviously there's a safety hazard there, but the main thing is it's a performance to hit to performance, isn't it? And speed restrictions, and it's a hit to budget from unplanned expenditure on replacing S&C units and things like that. So the standards are being altered. So new crossings you buy are designed to be more robust. But some work done by Leeds University actually was quite interesting in that this diagram here they produced, and these are not railway specialists by any manner of means, but basically indicated that if you actually went out and did a bit more maintenance on the crossings, so this is looking over a 10-year horizon. So I now describe it as a preventative approach will save money. So for a 10-year horizon, even if the cost of delay is not included, for CV13 crossover, it's still not an optimal crossing life, but we've increased the crossing life by about 5 times by the addition of 11 packing shifts to get rid of voiding and assure good geometry, and 8 resurfacing shifts to maintain the wheel transfer area and hence the wheel trajectory over there. And as you can see, it's potentially quite significant savings in that. Right. As I said, I was going to say something about rewarding the bad behaviour. So in Wales, this is Llandudno, I will name the guilty, Llandudno Junction 459 Alpha Points. So the local maintenance team were lauded in Connect and all the rest of it for putting passengers first by carrying out emergency repairs which avoided a TSR and kept the line open. But is that good proactive maintenance? I don't think so. It was banging like hell, this crossing, and you can see the extent of the lipping on it. To add insult to injury, it was just outside the section manager's office as well. So I think we need to be careful about rewarding. Whilst it is important to reward people for going the extra mile, I don't think we want to spend too much time rewarding people for fixing things that they should have fixed in the first place. Yeah. We need to start rewarding people who maintain assets at the lowest life cycle cost, or can understand and explain why they're not managing to do that. So a proactive approach will achieve better performance and longer asset life. There is a year to achieve compliance. This was 1054. And actually start putting the maintenance regime. And the preliminary work means that the focus changed from inspecting every crossing at the same interval to a risk-based approach to it. So that's really my my thoughts on what proactive maintenance is all about. So I'd like to sort of throw it home for a bit of a discussion now, really. So I've got my thoughts about why we aren't doing it so well, and things like that. But over to you, really. So is everything going as well as it should? What are the immediate challenges and what are the longer term industry challenges, do you think? Any questions?
Thanks, Andy. I think if people want to put a question in the chat, if they don't necessarily want to speak up, that's absolutely fine, and I'll pick it up from the chat, and perhaps we can get some discussion going from there.
I'm sure
but people are putting their hands up as well, so I think I can see Paul's put his hand up. So yeah, fire away, Paul.
Just what you were saying about the rails, Andy, and no 3Ms. When we brought RBM in at Ashford, it was probably the best thing we ever did. We banished 3M defects and gave them all a maximum timescale of M12.
Yeah.
Since the pain of getting them out, which was for the first year, was quite a lot of extra work.
Yeah.
They have been 100% the lowest RDMS numbers in Kent ever since, and it makes their management of rails a lot easier. And it's a legacy that I left Greg with, and I'm sure he likes now. He doesn't have to write so many TVs for rails overdue.
No, and it's a good. I mean, I don't claim any great spectacular knowledge for what we did in Wales. It just seems to be applying a logical pattern to dealing with it. Yeah, deal with them when they're small. Deal with them when you can make time to do it properly, and just keep on top of it. Yeah, it's about it is. There's an element of keeping the faith as well. As you said, the first year is a bit of a mad shuffling around because you're trying to manage both systems, but it's certainly worth doing. Thank you, Paul. Any other comments, thoughts?
From me, Andy, we've talked a lot about rail management,
Yeah,
and also just a little bit of a chat about maintaining top and line and just track geometry. What's the? I'm a little bit out of things these days, but what's the current thinking on stone blower versus tamping, and are there any? I guess it comes down to the level or quality of the inspection, what information you've got that leads you to be able to plan interventions in to prevent track geometry deteriorating quickly. So what's the latest on track geometry? Is that
yeah, so again, if you follow the reliability centered maintenance route, then most of the sections you've done that make the action limit fault the trigger for action. Yeah, so you're dealing with things much sooner. So you're not waiting for swamp before you go and fix the wet beds. You've got plenty of time to tamp or to plan a tamp or a stone blower to get in there. You've got time to do a survey if you need to do a survey. You don't always need to, but generally you've got a chance to do a survey. You've got time to make sure the site's prepared. And the overall result has been that the sections that have really managed to deliver on it, and Port Talbot was one, Hereford was another, got to the point where they were having no level 2 faults at all in their plain line CWR. So again, you can actually really start getting on top of this. In terms of stone blowing versus tamping, they both do a good job under the right conditions. So if you've got good clean ballast, then a tamper will do a perfectly good job. And we've certainly found now on Western that we're using the DTS, including on S&C now. And we found that by doing a design, tamping, and then following it with DTS, we are achieving very, very high track quality. And also, importantly, by taking out that early, unplanned settlement, we're also finding we're getting really good life out of it. It's very, very slowly degrades. So that's been a big success we're doing. And I'm not sure nationally where that's going, but we've sort of cracked on with it. And it's particularly on our S&C, we've achieving really good results with that. On our rural routes, I think stone blowing has proved to be a real godsend, because it can cope more with ore ballast. But there are places where even that's not going to work anymore, and you just have to make sure that you do the reballasting. So, but again, stone blowing is much more effective if you prepared the site well. So made sure everything's fixed down nicely. Make sure there's plenty of ballast on site, because you will use up quite a lot of ballast. And let the machine do what it wants to do as well. So if it says it needs to give it a good lift, it needs to give it a good lift. There's always a bit of a tendency, I think, to dial things off if it's looking scary. But So
okay.
yeah, so the new generation of stone blowers, of course, are all going to be multi-purpose as well. So you can use them for S&C and things, or you can use them as plain line without paying the penalty in slowing the machine down. So yeah.
Okay. All right. Paul, do you want to? You've got your hand up again.
Yeah.
Yeah.
Wow. Two things. I was going to start talking about track quality for level 2 type stuff, and then you mentioned stone blowers. You would know that XTD used to be our CTR1. We started a whole life cycle of in the wrong way. We started stone blowing it first. I had stone blowers on it for 20 years. Now I hardly see a stone blowing shift in a year now. And we've gone back to tamping, which just seems we did things arse about face.
Absolutely.
And now I'm suffering the consequences because I've got ballast full of fines from stone blowing, and tamping does not last as long as it should do because it's still got that 2 inches of chippings underneath.
Yeah.
No,
I think that where it seems to be working well is people have managed to say, right, this is now a stone blower site. Because it's responding to that. Usually the second cycle achieves the best result. So the first time you get an improvement, but the second time you do it, you get a much more longer lasting improvement. And we've certainly we get a mix of tampers and stone blowers. I don't know how it's planned down on. So the way it's planned in Wales, for example, is we have a route on track machine engineer who does the initial plan based on track quality and known problem sites and all these things that we put in. And then we have an iteration where the TMEs put in what they want to do and what machines to do. So we've made sure we've got a mix of machines which does deliver what the TMEs want.
I think we got lost a few years ago with clay banks and SMD and what was the best use for the access. And certain years it will be stick with tamping because you won't get the longevity out of the stone blower anyway, and you just need to tamp it. And I think we've gone the wrong way now. It's always tamper because we seem to not have the access to the stone blowers anymore. The level 2 thing, I hadn't thought it in the right way. We have gone totally the opposite way to what you are. We are now dispensating, mitigating twist faults up to heading towards 18 mil now, going, well, we're not having the right type of freight or traffic to have a derailment due to a twist fault so much. We've had them in the track now for a year, some of them. We've seen no further deterioration, so let's extend timescales. So we are thinking differently, and just listening to what you were saying has made me going to make a note for tomorrow. It's not that it's safe to run over a twist at 18 mil with the type of wagons we've got anymore now. It's the fact that what are we doing to the asset as a whole by not repairing it sooner?
Yeah, that's what.
Remember, and that's the critical bit, isn't it? If you're leaving it there, then you're deteriorating the rest around it.
Yeah. So there's a couple of things I'd say on that. First of all, one is the risks that twist derailments are rarely caused by the track alone. They're usually caused by a vehicle with something else wrong with it. Again, it might not be actionably wrong with it, but the combination of the two is enough to cause a problem. As we saw at Sheffield, when the derailment there, the gauge spread, there was certainly a wagon in the train, which was much worse than the others. The other thing is regional railways did some work some years ago now on the basis of, well, now we've got these trains which ride really, really well. This is the first generation sprinters over quite poor track. And they're quite track friendly. Can we actually lower the standards of maintenance on the track? And the upshot is yes, you can. but all you're going to do is transfer the problems to the trains. So if you run a train over poor quality track, you're working the suspension much harder. And they found things like, because the sprinters were built to be lightweight and track friendly, they started getting things like frame cracking and excessive wear on the dampers and things like that. So we've got to think of ourselves as a system, haven't we? And generally speaking, not doing things one side of the Royal Rail interface is going to have consequences on the other. And we saw it the other way round when we had lots of trains with really stiff suspension, didn't we? Which is good for riding at high speed, but it slaughters the curved track by excessive wear and rolling contact fatigue.
Yeah. Okay. Thanks for that. Gary McFarlane's had his hand up for a while. Gary, do you want to jump in?
Hi, Andy. Yeah, as you know, I'm not maintenance. I'm renewals and stuff. So I suppose just a question about immediate challenges. Do you see the challenge through CP8 kind of increasing for proactive maintenance, considering there is a reduction really in track renewals, and most of the routes have kind of chosen to sweat the assets through CP8 as a reduction in cost? Can you see that proactive maintenance being even tougher, probably over the next 5 years?
I think it is, because we're already seeing the challenges from that. I think for me, the biggest, I think CP7 is going to be well, it's a bit like the regional railways maintenance holiday. You know, if you don't do any reballasting for 5 years, and then we are going to have a lot more sites which are going to be a lot more challenging to maintain. The first thing that will suffer is performance, because we're going to end up with more rough ride reports and probably more speed restrictions on for track geometry. So I think it's going to be a real challenge how we manage that at the moment. And of course, we aren't expanding the maintenance side of the business, are we? So.
Yeah, I did mean CP7. That's what I meant, not CP8. Sorry, I was jumping the gun there.
But the point is, the point is the modelling, because we do the high-level modelling of the network using Vetism, and that's very clearly indicating that by the end of CP7, things will have started getting worse in terms of train performance, numbers of rail defects, and things like that. Because the harder you work the track, the more things you get. So it is going to be a real challenge, and I think the loss of high output is going to be keenly felt in the future, because there doesn't seem to be much movement on replacing it.
Yeah. All right, thank you.
It's also quite interesting. I think the other challenge for the industry is to get our costs back down.
Yeah.
So if you I looked up how much track renewal cost in 1935, and then just escalated it for today's monetary values. So we should be doing a mile for £200,000. Yeah. Just on cost, you know, escalating that. So, and what we're paying now for a mile of, well, that's the kilometres, well, it's well over £1 million now, isn't it?
I think it's $1 million a kilometre for ballast cleaning, at least.
Yeah.
You know, something like that. But we're having a big challenge ourselves, and unit rate challenge. But we can see that. So that's what I mean, just from a good set of slides. But I can see it obviously getting harder for the maintenance guys through this next 5 years with the challenges ahead. But
I think we also, I think we need to start thinking like a railway company. That's all of us. I hope Great British Railways will change perhaps that focus, because the whole idea that you can't have access to do maintenance to the track is patently crazy. Because if we went along to our local train operators and said, look, Mr. Great Western Railway, you're only allowed to maintain your trains for 2 hours a week now, and you're going to do it in the dark, and we're going to pour water over while you do it, and go along with it. Because that's what effectively we're doing to ourselves, isn't it, by restricting access. So I think we need a much better look at access. But I think proactive maintenance is the way to deliver the most within the opportunities we do get as well. Because there is no benefit to anyone in letting the downscale. And if we don't deliver the full asset life, then we're just going to become more and more expensive, aren't we? So, and we don't have a very pro-rail government at the moment.
Okay,
Probably
thanks.
might-
Sorry, you say something?
No, carry on.
Oh, okay. One of the things we haven't spoken about with regard to preventative maintenance is targeting high category lines, or should I say, looking at the track category as a way of deciding how our maintenance strategies are arranged, and also S&C. I remember, maybe this is old hat now, but some time ago we were working on giving every set of points on the network, if you like, a score.
Yeah.
Or
Criticality score, yeah.
ranking them in order of importance across the network, and then using that score to sort of prioritise certain levels of proactive maintenance. I don't know if that's the right approach. I mean, at the end of the day, we've got to keep the railway safe wherever it is, low category lines as well as high category lines. So maybe that's the reason why, it's not done in that way. But is there any mileage in having a strategy which targets particular lines according to importance, speed, tonnage, that sort of thing? I would have thought so.
Absolutely. I think in terms of unfortunately, we're now sort of going down a business model which says we only spend the money, where the performance is bad. That's, to me, not really the way of doing it, because it doesn't mean you spend anything on Western, you don't spend anything west of Reading. So yes, it's got to be focused. I mean, the first good thing that came out of the points criticality thing was it highlighted a load of S&C, which is not doing anything at all. It's never used. And we certainly had a big campaign during CP. During CP5 to get rid of a lot of it. And that was a great start. And we also put in more challenge now when we're remodeling to say, look, can we simplify this layout? We can give you the flexibility you want, but do you really need all this? So there's going there. In terms of the maintenance, I think reliability centered maintenance does drive that behavior, because the question you ask yourself there is it's about functionality. What functionality do I want from this piece of S&C, for example? So, and if you start thinking in life in terms of tons, not years, you can apply it quite well. So you do the same things everywhere, but the frequency with which you do them, you can allow it to be pushed out quite a long way on some of our lightly used routes. Because you've got time to get in and do work on it and things like that. So, and I think renewal or lack of renewal is also going to drive that kind of approach. So we need to, and if you want to keep the performance up, it's about going in early. But we need more system thinking as well. So we need to work closer with our S&T colleagues, on points operating equipment and things like that to make sure it's all working as a system together. So
Okay. And plain line pattern recognition, is that still a thing is that changing things?
Yeah, very much so. I mean, it's still it's changed a lot because it got rid of basic level visual inspection on a lot of our plain line CWR, and it's proving quite successful because it's better than a BVI in that you get a track geometry recording and you get pictures of the things that are going wrong. There's some work going on at the moment using because machine learning has come an enormous way since we first started down that road, and we're finding that teaching the system now is much easier. You just need to show it lots of pictures, and it learns quite quickly to find the things you want. So that's been really useful. So we are looking at doing more with this kind of thing. So we're going to have a better ballast management system that's being developed at the moment. And things like the Aviva video recordings is also really useful. Very high definition video as well for following up on stuff and actually seeing what's going on site. So
yeah, and are you using drone technology for taking photographs of the track from the air?
Personally, I don't think it's got the biggest use in track. We're using it for surveying now, which is quite handy. It's the trouble with drones is the bit that we're losing out of track inspection is to go in and having a look with the train running, watching the train over it and listening to what's happening and that. And I don't think drones are really good at that. Where drones really have taken off, though, is management of line side, because with the various models they use now, you can survey miles and miles of line side without having to hack your way through the jungle to get up to the fence line and things like that. You can go and look at it from, and we have models now which look at health of trees and things like that. So it's having a bigger effect there. So
yeah, you make a good point about losing that sort of ability to watch a train over a defect, which was something I valued when I was involved in track maintenance. I always thought it was, you could get a lot more information from standing line side and seeing the train go over a defect, or a very poor block joint or wet beds or whatever it was, and I think the other thing was wet beds particularly. I found there was a bit of a lack of understanding about wet beds across the industry a bit, because I always like to think of them as either top down or bottom up. And most of the wet beds I had on my patch were top down. You had some where there was formation failure, you had pumping action from underneath, but a lot of the pumping was from either a dip joint or a defect on the running surface of the rail. It was giving an impact, and we used to go in and dig it out and find that the formation underneath was perfectly good, but all of the ballast was completely slurried and it was in a poor state. So understanding the difference between a top-down defect and a bottom-up defect with wet beds was I very rarely came across anybody that spoke about that. When I was involved.
I used to work. To me, you can often work out what's going on by just feeling the paste, can't you? If it's sleeper and ballast, it's generally grey or white and gritty, isn't it? But obviously, if you've got clay coming up through it, it tends to be very smooth, doesn't it?
But you can tell the difference. That's for sure. You can immediately see whether it is coming up pumping from the bottom. Formation failure, but
one of the things which has gone with a lot of access is good work scoping. So I think that's another challenge for us. So to me, a good scope of work is going to get to the bottom of what needs fixing, isn't it? It's about and this is underpins proactive maintenance. So you only go and do it once. So you've worked out the problem here is drainage. So the first thing we need to do is clean the drains. Then we need to dig some ballast out and regrade it. And then we need to restore the geometry on the track. But we don't do enough work scoping, or we don't do it well enough. So the result is you end up with a plan which is it's palliative. It addresses the symptoms and not the cause. And I think that is another challenge for the industry, is how we can do that. So things like the video trains, the AVA videos and things like that are really useful to help that kind of initial look at the site and scoping up what's going on there.
Okay, I don't know if we've got any more questions. We're just on 4 o'clock now. So unless anybody else has got any more questions, I'll draw a line under discussions. Just check the chat, see if you've got anything in there. Yeah. Yeah, I think Gary's already mentioned his point there. Okay. All right, Andy, it's been brilliant for you to come along and give us this talk today. You're always very welcome to give us the benefit of your knowledge and experience. I think Colin introduced you saying you've been on the railways for about 40 years. I'm sure it's actually 50.
I'm in my 50th year this year.
Yeah,
So.
yeah, which is amazing. Yeah, you've been in this industry a long time and given the industry a massive contribution, and benefit of your knowledge today has been really good, and we've had a good discussion as well. So thanks very much for spending the time to come along and talk and prepare the slides for us today. It's much appreciated.
Okay.
Yeah. Okay, so thanks very much. And thanks to everybody for joining the meeting today, and take care and stay safe.
Okay.